Hello guys, this is Dr. Manjunath Chennapgod from Anveshana Academy, Bangalore, India. Dear students, in the previous class we were discussing about what is thermodynamic state, what are the examples for thermodynamic state, and what is change of state, and what are the live examples for change of state that we have discussed. Later we discussed about what is thermodynamic path and what are the examples for thermodynamic path we have in detail we have discussed. Later we have discussed about thermodynamic cycle also. What is thermodynamic cycle and what are the examples for thermodynamic cycle in detail we have discussed in the previous class. Dear students, we'll move towards next topic, that is thermodynamic process. Okay, dear students, first I will try to read the definition of the thermodynamic process, then I will try to explain you what is thermodynamic process with the help of some live and technical examples. Okay, fine. Now, dear students, you can see here now. What is thermodynamic process? Any change that a system undergoes from one equilibrium state to another equilibrium state due to change in properties like temperature, pressure, volume is called as process. I repeat, any change that a system undergoes from one equilibrium state to another equilibrium state due to change in properties like temperature, pressure and volume, etc. is called as a process. Okay. Later, then the series of states through which a system passes during a process, that is called as path of the process. That is nothing but what? Thermodynamic path. Okay. What is thermodynamic process here now? You can see here now, when a system undergoes from one equilibrium state to another equilibrium state due to change in properties like pressure and temperature and volume is known to be thermodynamic process. That you can see here now. How it is, dear students? You can see here now. I will try to take a diagram. Okay, so vertically I will take one property, horizontally I will take another property. I will nominate these properties, one as A, another one is a B, dear students. Now assume that the system is at this particular point. Now assume you can take any system, assume that one system is at this particular point, that's the initial point, or we can call it state 1. Then the properties of the system at point 1 will be P1 and T1. I will take three important properties here now. Macroscopic properties: pressure, volume and temperature. When it is at initial condition, it is having P1, V1 and T1. Assume that, dear students, if the system moved from point 1 to point 2, then the properties of the system is going to change. That means what? P2, the pressure will become P2, volume will become V2, temperature will become T2. That means what? When a system undergoes when it is at particular state 1, right, it is at a constant. That means what? Pressure is constant, volume remains constant, there is no variations in the temperature. That means it is under equilibrium condition. What is equilibrium? When I am going to explain you zeroth law of thermodynamics in detail, I will explain you what is equilibrium. There, when it comes to equilibrium, thermal equilibrium will come, mechanical equilibrium will come, chemical equilibrium will come, dear students. That means what? Constant, or there is no any fluctuations in the system. That means what? When system is at particular point 1, it is having pressure P1, V1 and T1. That means what? It's an equilibrium condition. At point 1, system is at equilibrium condition. Once the piston moved from point 1 to point 2, it is going to attain one more equilibrium state. That is nothing but what? State 2. The properties of the system changed from P1 to P2, V1 to V2, T1 to T2. There is a change in properties of the system, but system is going to attain equilibrium at point 2 also. That means what? One also equilibrium, second also equilibrium. That means when a system undergoes one equilibrium state to another equilibrium state due to change in properties like pressure, volume and temperature, that we can call it as a thermodynamic process. Okay, dear students, when I am telling system will move from point 1 to point 2, immediately it will not move, but it is going to cross series of states. When the system is going to cross the series of states, right, when you are going to join these states, right, you are going to get a curve or a trace. That trace or a curve we can call it as a process path, dear students. Now what is that? Process path is nothing but what? When a system undergoes series of states, that path or a trace we can call it as a thermodynamic path, or we can call it as a process path. Okay. Okay, now to understand that, we can take one more example, live example. Balloon. Whenever we are going to fill the gas into the balloon, right, what will happen now? It is going to expand. But when it is initial condition, right, that initial condition I will mark it as a 1. Then volume of that gas balloon is V1. I will assume that 0. There is no any volume at all. Pressure I will take 1 bar. Example. When we are going to fill the gas into the balloon, right, the balloon is going to expand. When the balloon expand, right, assume that pressure increase to 1.5 bar, then volume increase to V2 increase to 2 bar actually. So our 2 bar 2 meter cube you can take it, or 1 meter cube you can take it, dear students. Now that means what? It is a state 1, it is a state 1 and it is a state 2, dear students. Now okay, the properties are changed. Okay, initially when it is at point 1, right, at state 1, right, it is having an equilibrium state. That means what? It is having volume 0, pressure 1. That pressure remains constant throughout the system. It is equilibrium state 1. When you fill the gas into the cylinder, right, gas into the balloon, right, the balloon expanded, the volume increased. That means what? The pressure also increased, volume also increased. Okay, if the properties are changed, but again over a period of time it is going to attain an equilibrium state. That means what? The system undergoes from one equilibrium state to another equilibrium state, whereas there may be change in properties like pressure, volume and temperature. That we can call it as a thermodynamic process. Okay, when a system undergoes one equilibrium state to another equilibrium state due to change in pressure, due to change in properties like temperature and pressure and volume, that we can call it as thermodynamic process. This is a live example, dear students. Now one example, technical examples you can take it, dear students. You know, assume that I will take a piston and cylinder arrangement. Inside gas is there. Okay, hot gas. Assume that hot gas is going to create, or it is going to exert explosive force over the surface of the piston. Hence the piston will start to move from point 1 to point 2. When piston moved from if the piston moved from point 1 to point 2, that means what? Expansion will takes place. If expansion takes place, that process we can call it as a expansion process. But that expansion immediately it will not take. Piston will not come from one point to second point immediately. It is going to cross a series of states. When we are going to join these all state, right, then that curve or a trace we can call it as a thermodynamic path, where when the piston is at particular point 1, right, again it is at an equilibrium condition. When it is at state 1, that is equilibrium state, the properties at state 1 we can call it as a P1, V1 and T1. When it reaches from point 1 to point 2, the properties they are going to change, that is P2, V2 and T2. But again here also equilibrium. That means what? Again the pressure and it is going to attain the equilibrium condition. That is known to be what? When if the system undergoes from one equilibrium state to another equilibrium state due to cause of pressure, temperature or volume, that we can call it as a thermodynamic process. That variation of that means what here now? Variation of pressure and volume we can see here now. That variation of pressure and volume we can express or we can show in PV diagram. That you can see here now, dear students. Now okay, so vertical I will take it pressure, horizontal I will take a volume, that is V1 and V2. Okay, now assume that when the piston is at particular point 1, right, that is nothing but what? Our initial condition or starting condition or state 1 or initial condition, that I will mark it as a 1. Once the piston moved from point 1 to point 2, volume increases but pressure decreases. That we can see here now. That means what? You can show it the volume increasing. So dear students, you can see now volume increasing when the piston moved from point 1 to point 2, volume increases whereas pressure decreases. That means what? System, when piston is at particular point 1, right, it is an equilibrium condition 1. Then when it reaches at second 2, right, again it is going to attain equilibrium state. That means what? 2. Once the system undergoes one equilibrium state to another equilibrium state where the properties of the system may change, that is known to be what? Thermodynamic process. That is known to be thermodynamic process. But it will not immediately, it will not come from 1 to 2, but it is going to cross a series of states. If you are going to join these all series of states, then you are going to get a curve or a trace. That curve or a trace we can call it as a thermodynamic process path, dear students. Okay, Now we'll move towards what is thermodynamic process and what are the examples for this thermodynamic process. We can see again. You can see here now. With some animation, I will try to explain you what is thermodynamic process. When it comes to engine, there will be two processes. The four processes will be there, but here I will take two important processes. One is compression process, another one is expansion process. That you can see here, dear students, now. Okay, so now if it is an expansion process, dear students, so piston is moving from one point to 2, that means what? TDC to BDC, TDC to BDC, you can mark. When it moves from TDC to BDC, expansion will take place. When it is moving to 1 to 2, right, that pressure variations, that you can show it on the PV diagram. That means what? Expansion process, we can say, dear students, now. Similarly, here you can take compression. If it is reverse, if it is the piston is moved from, okay, it is compression process, dear students. Piston is moving from 2 to 1. Okay, 2 to 1. When you are going to join these all things, right, you are going to get the curve. That curve or a trace we can call it as a thermodynamic process path, dear students. That because you have to see the directions here now. That is important. Piston is moving from 1 to 2, 2 to 1. 1 to 2 is expansion, right? That means what? Volume increases, pressure decreases. That you can see it now, the direction. If the piston moved from 1 to 2, expansion process, dear students. When the piston moved from 2 to 1, that means what? BDC to TDC, you can call. That is nothing but what? Compression process. Okay, this is one kind of okay, now okay, when it comes to this thermodynamic process, that you can see now, dear students, as I told, it is going to have an initial state. How it is, that you can see now. Assume that bus is a system. When is at starting point, right, it is going to have some properties. That properties we can mark it as a P1, V1 and T1. That condition we can call this the initial condition or state 1. Okay, that is nothing but what? The system begins in a equilibrium. Again, it is in a equilibrium state. Okay, fine. Then when it is going to move from state 1 to state 2. Okay, from point 1 to point 2. When it is going to reach point 2, right, that again it will be equilibrium state. Okay, when it is equilibrium state, right, immediately it will not come from point 1 to point 2, but it is going to cross series of states. That I will show you, dear students. It is going to cross series of states. When you are going to join these all series of states, right, you are going to get a trace or a curve that we can call it as a process path, dear students. Okay, fine. That is what? Process path. This we can call it as a path. Thermodynamic path or process path, we can say. When it is going to reach a second point, right, that point we can call it as a final state. Again, the system is going to attain an equilibrium condition. That state we can call it as a final state, dear students. Now the system reaches a new equilibrium state, that is known to be final state. But when system moved from point 1 to point 2, right, there is some energy and mass exchanges takes place between system to the surrounding. That means what? You can see now, heat energy is going to convert it into work. Again, sometimes work is going to convert it into heat, or sometimes heat is going to loss. That means what? Energy exchange takes place when system moved from point 1 to point 2. That means there will be energy and mass interaction will take place with the system and surrounding. This is what? Thermodynamic process. To understand the basic principle or concept of thermodynamic process, you can see it now. Okay, when it comes to this thermodynamic process, based upon the macroscopic properties of the system, we can classify different types of thermodynamic process. That you can see here now. What are those properties? Based upon the properties, either it may be pressure, either it may be volume, either it may be temperature. So if during a process, right, assume that piston is moving from point 1 to point 2, again it will move back from 2 to 1. If the piston, now assume that if the piston is moving from 1 to 2, that is the expansion process I told. During that expansion process, if the temperature remains constant, that process we can call it as an isothermal process. When the piston moved from point 1 to point 2, if the pressure remains constant, that we can call it as an isobaric process. If the volume remains constant, that process we can call it as an isochoric process. If there is no heat transfer from system to the surrounding, that process we can call it as a adiabatic process. If there is a constant entropy, then that process we can call it as a isentropic process. If the fluid involves, then we are going to get one process. That process we can call it as a throttling pressure. Sorry, throttling process. That means what? Pressure is going to decrease. That we can see with the help of examples in upcoming classes. Okay. Then polytropic process, where PV to the power of n is equal to constant. This process, these all are the different types of process based upon the properties of the system. Dear students, in upcoming class in detail, I am going to discuss what is isothermal, isobaric, isochoric and all this process with the help of diagrams, and I am going to derive some equation. In detail, I am going to discuss in upcoming classes. But when it comes to thermodynamic process, there are different types of processes we can get based upon the properties of the system. Okay, fine. Let's come, we will move towards next topic. Okay, so that here I am going to display one more example, live examples of these processes. What you have seen, right? Thermodynamic process, isothermal process, temperature remains constant, volume remains constant, isochoric, if the pressure remains constant, isobaric. That you can see here now, working of the thermodynamic processes that you can see here, dear students. Okay, now what are the example for this different types of process that you can see here, dear students? Now, as I told, when it comes to isothermal process, temperature remains constant. When it comes to adiabatic process, there is no heat transfer. When it comes to isochoric process, volume remains constant. Isobaric, pressure remains constant. Okay, what are the example for this processes that you can see here now? Throttling process, refrigeration you can take. Isobaric, you can take heating water. Isochoric, you can take heating gas. Polytropic process, that is a PV to the power of n equal to gas constant, a constant. Adiabatic process, that we can take engine compression. Isothermal process, phase change. Isentropic process, turbine expansion. Fine. These all are the examples for different types of thermodynamic process. Okay. Dear students, next, this thermodynamic process we can express in terms of different types of diagram. One is PV diagram, TS diagram and HS diagram, dear students. Now, what is PV diagram? That you can see now. PV diagram, the name itself indicates here. P means pressure, V represents volume. Then with help of this PV diagram, what we can do, we can calculate the work done by the system or work done on the system. This is PV diagram. Okay. Next one, TS diagram, where T represents temperature, where S represents entropy. With the help of this temperature and entropy or TS diagram, we can calculate the rate of heat transfer. We can calculate the heat transfer. Okay, fine. Now, third one, HS diagram, where H represents enthalpy, S represents entropy. Okay, HS diagram. With the help of this enthalpy and entropy or HS diagram, we can do steam analysis or we can calculate heat, how much amount of heat transferred also. That is HS diagram. These three diagrams are very important to calculate the work done or heat transfer in thermodynamic system. Okay, fine. Now, dear students, I hope you understood today's class. If you have any doubt, you can ask me. And if you really like the video, do comment, like and subscribe and share to your friends. I hope you enjoyed my videos. Thank you.